Hi guys. So on the last video, we we put together a very simple circuit which included a microcontroller. In my case, it was a Teensy and an LED circuit, and we basically used code to program the microcontroller to control the LED to blink a certain amount of times in a second. Now, we understood that while very pretty, it wasn't very practical trying to change the rate of blink because we always had to go back to the code, change the code, and then re-upload. And that was quite time consuming and it's not very practical. Um, it's it's nice for proof of concept, but for practicality, you want to be able to change the blink delay by yourself without a computer. So if we were to unplug the microcontroller and attach it to the power source, even without having a computer around, we should be able to control the blink delay. So we are going to make some minor modifications to our circuit. Now, just to clarify some certain things, the blue box here, that is a resistor, and that has a value of about 220 ohms as we measured. This green circle here, is a green LED. It can be any LED you want. It's a green LED. And here's our black microcontroller. So if I just put an arrow there, that's our microcontroller. This is what controls the behavior of the rest of our circuit on the circuit board. And as we saw in the schematic, on the top right corner of the microcontroller, this is our V in, and that has a range of, if I recall correctly, 3.6 volts to 6 volts. And we have our ground, which is the standard circuit symbol, three parallel lines like that. And we have voltage in along this red strip and ground along this blue strip. To be fair, I typically prefer to have voltage in on the opposing strip over here and ground there, but you can do it any way you like. And this pin here, currently we have this pin as number 23, I believe. Yes, pin number 23. That pin there is pin 23, and this is what we use to point to in the Arduino ICE when we were writing our code. So we basically gave instructions to the microcontroller to do stuff on pin 23, basically make this LED blink the way we want. The modification that we're going to do is that we are going to introduce a new circuit component, and this circuit component is called a potentiometer. Now, a potentiometer, it has the circuit symbol that. So this is the typical circuit symbol for a resistor, but this arrow basically indicates that we can choose the resistance. Now the potentiometer is going to have 3 pins, and I'm going to put 1 pin here, as in just to show you guys. Now, 1 pin is obviously towards ground. 1 pin is towards ground. The other pin is where it gets its voltage from. So remember in the last video, I told you that even though we were going to plug voltage in onto the red strip, we weren't going to use it right then. We're going to use it now. So one of the pins is going to go straight to voltage in, and this pin is going to be at ground, and this LED also has a pin at ground. Now the third pin is going to be the analog input pin, and on our schematic of, well, on my schematic of the Teensy, the analog inputs are down here somewhere. So I'm just going to denote one pin there, and I'm going to call that pin A0. That basically stands for pin analog 0. That doesn't actually look like a 0. Just do that properly. Pin analog 0. So I'm going to connect the third pin of the potentiometer to this analog input, and I'm just looking for a color to use. Let me just use green. So I'm going to use a jumper wire, and I'm going to have that go to that pin there. Now we are going to program. We're going to modify the code and program the microcontroller such that when we tune this potentiometer, we end up varying the blink delay on the actual LED. So let's put the circuit together, and then we will code what the circuit will do. So this is our original circuit, and as you can see, I haven't changed it at all. It's still got the LED. It's still got the LED. One pin is going to ground. The other pin is connected in series with this resistor, which eventually ends up at pin 23, which is a pulse width modulated output pin number 23. I have voltage coming from the volts in of my microcontroller and making this whole strip live with voltage, and then my ground pin leads from my microcontroller to this blue side of the strip, which makes this whole strip ground. So the modification that we're going to make is using this potentiometer. So a potentiometer is actually a very simple component. It's really just a fancy variable resistor, right? And what it has is that there's a wire strip in here, and as you turn this knob, you basically change the position of the connection inside the potentiometer, which links these pins to the actual wire strip inside. You can't see the wire strip inside because obviously if it was exposed to the atmosphere, it would erode quite quickly and it would break the potentiometer. But the wire strip is hidden inside. So turning this knob basically changes how much of that wire strip we are in contact with. When it's on its full range, we have enough wire strips so that we have a total resistance of 10,000 ohms. When we turn it all the way in the other direction, we have so little wire strip that it's either 0 or close to 0 or something like that. I don't quite know the lower limit of the of this potentiometer, but the upper limit is 10,000 ohms. So this is classified as a 10,000 ohm potentiometer. So what I'm going to do is that I'm just going to plug this potentiometer fully on the circuit board here. Okay, so I've plugged it in there. Now these two pins, one pin will go to ground, the other pin will go to live. This pin here, this pin will be our analog input. So first of all, let's connect these two pins to ground and live. So I'm going to use a white jumper wire for ground, and I've already looked at the schematic of the potentiometer, and the ground pin is the rightmost pin. So I'm going to connect that to ground as so. And I'm going to use a blue jumper wire to connect it to live. And that's the leftmost pin. And I'm going to connect that to live as so. So this is how it should look so far. Last but not least, we're going to have a look at our schematic again. Well, my schematic. And it says here that Well, in fact, all of these can be analog inputs. All of these can be analog inputs as shown by the A. But I'm gonna choose pin 14 as my analog input. So that means I'm gonna plug a jumper wire from the potentiometer's pin there, from the potentiometer's pin there to this pin on the Teensy right in the middle there, like exactly at the center point of my finger. So let's do that. Plug that there, and then wind it all the way to here, and that should be pin number 14. And that's the modification that we will make to our circuit. Basically, all we've done is plug a potentiometer into the circuit. Let's give some instructions to the potentiometer now to manually control the blink even without uploading new code onto the microcontroller. So this was our previous blink using time delay code that we wrote in the previous video to control the blink speed on the LED, and we are going to make some minor changes. So the first thing I'm going to do is that I'm going to copy this, open up a new sketch, and just paste that in, and then close this. And I'm going to make an edit in the comment here saying this time delay is controlled via a manual analog potentiometer. Okay, now we've already quote unquote initialized the green LED here. The actual initialization happens here. This is you don't actually need to do this. You can actually just put a pin number right here. You don't actually need to put green LED here. You can literally just put 23 or int 23, whichever output. But I like to give every single constant and every single variable a meaningful name. That is why I do a pre-initialization here. I'm also going to pre-initialize the potentiometer, and I'm going to give it a meaningful name. I'm just going to call it potentiometer. Now, currently, this potentiometer, as you saw, is plugged onto pin A0. It's plugged onto pin A0. Now, the reason why I'm using A0 rather than pin 14 is because from what little I know, and I say little very tenuously because, you know, since I use these on and off at work, I know a bit more than I'm letting on, but teaching it's a different thing. So from what little I know, the numbers are meant to be outputs, whereas when you state a letter plus a number, it's meant to be an input. Or that's the convention that I've learned to deal with. Okay, so here's me naming pin A0 as the potentiometer input, and I follow the same thing here where I define a second pin mode. The pin is called potentiometer, but rather than be an output, it's actually an input. So I have to use the keyword input. This particular pin is an input, so it gives instructions. Okay. Another thing I need to do is that I need to initialize a serial. Now serial is the keyword that defines communications between the microcontroller and a component on the circuit. And the so-called port I've given it is 9600. So serial begin is basically me initializing communications. So initializing communication between microcontroller and component. Now, this will still run repeatedly, but with minor changes. However, before we do all of that, we need to write some code that basically allows the potentiometer to send instructions to the microcontroller, which would therefore affect the green LED. The first thing that we are going to do is that we are going to use the keyword serial. So that's the keyword for, communication. And we are going to print lines. And we are going to print lines based upon the potentiometer. The second thing that we're going to do is that we are going to initialize another variable. This will also be an integer. And we're going to call this integer potentiometer value. So basically what we're doing is that when we turn the potentiometer, a value of what number that we're on, or what resistance we have turned to on the potentiometer, will be relayed to the microcontroller. And this can only happen using the keyword analog read. And it's reading from the potentiometer. So the potentiometer value is read from the potentiometer using the keyword analog read. And we are going to use this value to define what the delay is. Okay. So all we're going to do right now is that we are going to take this value and then just plug it in there. Just plug it in there. Now, because it's a 10K resistor, these potentiometer values, I assume, should be able to go from 0 to 10,000. So if we twist the potentiometer to like 9,000, 9,000 would appear here, and the LED would be blinking. It would take like 9,000 times to blink, or I mean, it would have a time delay of 9,000, which is very slow. Like it would take 9 seconds to blink, or something relative to that. I'm not too sure of the exact values. We can write some more code to actually print what those values would be, but I'm not going to do that right now. I just want to make things blink. So the last steps that we're going to do is that we're going to verify, and I'm going to call this blink potentiometer 2. Save. So the verify code should look for any errors or tell me if the code is good. Is it all good? It's taking its sweet time. It's all good. Great. So now I'm going to connect my microcontroller to my computer. You heard that. And I'm going to upload the code. Okay. So no longer do we need to use the code to change the code and have the code define how fast it can blink. We can simply use the potentiometer. And this, guys, is the finished product. So as you can see, I've got the potentiometer on a setting where it's blinking quite fast. And if I twist it to slightly another setting, it blinks even slower. It's very, very sensitive. It's almost too sensitive. Just do it a bit on the side. And it's blinking so fast that it looks like it's on all the time. And then back again. So sensitive. That's what I get for buying a cheap potentiometer. There we are.